Okay, this is another question related to your wave topic or
Okay.
superposition. Uh, because this question contains the concept of diffraction in the. So let's solve this one and find out what is new in this question. Okay, so basically in part A, for a progressive wave state, what is meant by wavelength? So what is the basic definition of wavelength? You just need to write the basic definition, and the basic definition you already know about it, distance between two consecutive crust or two consecutive wave fronts. So that is the definition of the wavelength.
So it's the length between the distance between like two consecutive
Yes,
troughs.
distance between consecutive trough or crust, or you may simply write wave fronts. It's up to you. So it a distance between consecutive crust or trough, the term. Uh, okay. Next, a laser wave from a laser. Oh, sorry. A light wave from a laser has a wavelength of 460 nanometers in a vacuum. Calculate the period of the wave. So you need to
So,
calculate. Yes.
so what we're gonna do is we're gonna find out the frequency, I think.
Okay.
And then using the frequency, we can like find out what the time period
Is okay.
was, because frequency is 1 divided by t.
Yes, that was fine. And how we find out the frequency first?
Frequency, do we do it? Okay, so we know that it's in a vacuum and the light, it's a light wave. So the speed of light is we're gonna use the formula V equals to frequency times lambda. So we know V is 3 times 10 to the power of 8, and then we don't know what the frequency is, and the wavelength is 460 nanometers. So we're going to do 460 multiplied by 10 to the power of um, -9, right? And then we're going to divide 3 times 10 to the power of 8 by 460 multiplied by 10 to the power of -9.
Yes. So you know that light, the speed of light is a universal constant, so it will remain constant everywhere. So we are talking about when we travel with 3 into 10 to the power 8. So we just simply find out the value of frequency first, and then we divide t equals 1 over. It will give you the value of time period, and you can see that question is very simple, only a single trick of the light wave. So you just simply find out the time period, that will give you 3 marks, right? So
Yeah. So the frequency which you're gonna get is 6.5 times 10 to the power of 14 hertz. And then you're just gonna, to find out the time period, you're gonna do 1 divided by 6.5 times 10 to the power of 14, and then you're gonna get 1.5 times 10 to the power of -15.
okay, so time period is 1 point.
5 times 10 to the power of -15.
Okay. The light from the laser is incident normally on a diffraction grating. Describe the diffraction of the light waves as at the grating. So we know that when light enters through the diffraction grating, so it will incident normally. But describe, they are asking about the diffraction process, that after incident on the diffraction grating, describe the diffraction of the light wave at the grating. So basically what happens over here, you just need to explain this concept that we studied in diffraction grating, that when light strikes the diffraction grating, so initially it is moving in a straight line, and after striking the diffraction grating, it will split into different angles according to their geometrical shadow or anything we can say that. So you just need to simply explain that. when wave passes or light passes through the slit. When light passes through the slit, it's into different orders or the spread of will be geometric shadows, right? Geometric shadows, because we know they are at a specific angle, not everywhere, right? So there will be some specific pattern of the diffraction grating or dark and bright fringes on the screen, right? Because we equally line spaced line on the grating element, so that's why your angle on right hand side or left hand side will be almost like the same. So there will be a same pattern on the screen. Okay,
Okay.
question number D part. A diffraction grating is used with different wavelengths of visible light. The angle theta of the fourth order, so they are asking about the fourth order maximum from the zero order, that is the central maxima, is measured for each wavelength. So basically we are using a different wavelength, right? So we are not talking about multiple orders. Actually, we are talking about different lights of different wavelength, and we are just observing the fourth order maximum for each wavelength, right? So this is the question, and the variation of the wavelength lambda of sine theta is shown in figure 4.1. So basically we are using light which is from 4 nanometer to 700 nanometer, and it depends upon the angle also. So what is the question is, the gradient of the graph is G. Determine an expression in terms of D. So actually you need to find out the equation with in terms of G for the distance D between the centers of two adjacent slit in the diffraction grating.
Okay.
So this is your graphical representation. Uh, we know that a simple formula of this diffraction grating is equals to d sine theta is equals to n lambda. This is the main and general formula for this grating element. And we know that sine theta is directly proportional to lambda if we keep these two things constant, because we know that if we are using a grating element, so grating element will remain same, right? And order is also same, because in question it is mentioned fourth order, so order is constant, grating element is constant. So the other two factors are directly proportional because there is a straight line. Okay, so if we want to find
Okay.
the gradient, so gradient will be equal to same sine theta divided by lambda. So this is the concept which is mentioned in the question, right? And now we just need to drive the final expression that gives you the value of G. So your
Okay.
final expression will be like d sine theta is equals to n lambda, and D will be equal to, sorry, n over sine theta into and D is equals to lambda over sine theta. Okay, now you can see that in previous equation, we just simply write sine theta over lambda is equals to gradient. But if we want to write in the reverse order, so your lambda over sine theta will be equal to 1 over gradient, right? So that
Yeah.
will be reciprocal. So up to that situation, we just simply take the central value as the reciprocal gradient one. So your equation will be d equals to 1 over gradient into n. So basically, the gradient of the graph is g. So in question, it is mentioned you need to write capital G in the place of gradient. So this is your final equation. We know the value of n also,
So you can n divided by gradient. So
and there is also a value of n fourth order. So your final answer will be equal to d is equals to 4 over g. This is your final expression, right?
yeah.
The symbol that they were asking in the question, and we also include the same order which is mentioned in the question. And in final part of this question on figure 4.1, sketch a graph to show the result that would be obtained for second order maxima. So now we need to find a representation that we can obtain for the second order maxima. So if we use the same equation, because when they ask with the same part of the question, so usually it depends upon the, and the question is related to the same equation that we were using. So actually d is equals to 2 over g, because now we are going to find the second order maxima, and the value of g will be equal to 2 over d. And now let's try to mark on the diagram. So where will be your gradient? Any idea?
My gradient.
Yes, because we need to mark a graph to show the result that would be obtained for the second order maxima. So initially, the line which is already marked on the graph is for d is equals to 4 over g. And now we need to mark for this line which is 2 over g.
Mm, is it gonna be like steeper?
Okay. Okay, so you are saying that your graph will be more steeper.
Yeah, I'm not really sure.
Okay, you may take repeat the question and try to find out is anything in this question, because now we are almost at the last point to find out the final answer.
Okay. Oh, is it gonna be like half the gradient? Is the gradient gonna be like half of what it was before?
Yes, so your gradient will be half, because already you know that your actual value is 4. So that was for the fourth order, because if we consider these pattern, So your fourth order will be at greater angle, right? So now we are
Yeah.
at half of the original value, right? So that's good. You just need to draw a line that is now below the original line, right? Because our gradient is now half. So we just need to draw a line from the origin again. Let's suppose at space any random, because angle is not mentioned over there. So your line will be, let's suppose if we start from this point, so that will give you the concept of your new line. Okay, because you know
Okay.
your gradient is half, so we just make a line in the middle of this zero and the fourth order, right? Because this is zero, this is our fourth order. So we just need to make a line or like in the center, because values are not mentioned on y-axis. So we just make a line in the middle, right?
Yeah.
This is the question. Okay, your new question is, by reference to the direction of propagation of energy, state what is meant by a longitudinal wave. That is very simple.
Longitudinal wave is
Mhm.
it's like the sound waves, right?
Yes.
So the energy is in the same direction.
Okay.
It's
And
traveling.
yes, you may also use that basic definition of your IGCSE that is related to the vibration of the waves are parallel to the propagation, right?
Yeah. Also, is it P seismic or is it S seismic?
Yes. Uh, Vibration of the particles is parallel to the wave direction or the propagation of wave. You may use the both term, wave direction or propagation of wave. And the next question is, state the principle of superposition. Did you remember that the principle of superposition?
Yes, superposition is basically when two or more, or like, when there are two waves that
Yes,
have the same frequency, same wavelength, and they're
yes,
traveling in different directions,
yes,
and then they interfere with each other. So they're like overlapping and stuff. And then the resultant displacement would be the sum of each wave.
yes, very good. So you already know the complete statement for principle of superposition. So that was for 2 mark. And the next question is related to double slit experiment. And there is a distance marked over here. So which symbol we are using for this distance, the distance between the center of two slits? A, X, or D? If you remember that, yes. So basically, a small a is the distance between the center of the slit. So this distance will be equal to a, and the distance from screen to the slit is equals to capital D. So this distance is equals to capital D, and lambda may be in the question. Uh, okay, the separation of the adjacent bright fringe on the screen is 4.3 exponent minus 3. So actually this is the value of x. And they are asking about the wavelength, right? So first part is very simple. You just need to solve with the help of basic formula that ax is equals to lambda d, or ax over d will be equal to lambda. The same formula for double slit experiment, lambda is equals to ax over d. So the value of a is 3.7 exponent minus 4 multiplied by 4.3 into 10 to the power minus 3 divided by 2.3 meter. Okay, and one more thing, they are asking the wavelength in nanometer. So your answer will be in meters, and to convert into nanometer, you just need to multiply by 10 to the power minus 9. So that will give your value in nanometer. Okay.
Okay.
So this is a simple one. You just need to find out the values from the diagram. And the second part is the intensity of the light passing through each slit was initially the same. The intensity of the light through one of the slit is now reduced. So their main concern is related to the intensity of the slit of the light after passing through the slit. Now compare the appearance of the bright fringes before and after the change of intensity.
So the intensity is also reduced?
Uh, okay, so your intensity will also reduce, but what will be the other changes? Because you need to write for the 2 marks. So actually you need to compare between bright and after the change of intensity for bright fringes. So what are different changes we observe in the experiment? Let's suppose we also did a question in last class that is also related with the same part, that if intensity will be half, so what will be the change in your experiment? So first of all, if we talk about the fringe spacing, because we study this formula and we know the factors that we need to study about the distance between the consecutive fringes and the distance between screen and the slit, because distance between slit and scale remains constant. So we are not going to change that one. Yes, but the distance between the fringes may be different, right? So you may ask, or you may write with the reference of the distance between fringes. So is there any change in the fringe separation or not? Let's suppose if we are talking about two bright fringes, so after the intensity will change. So is there any change in the fringe separation or not? So
There will be.
actually there will be no change in fringe separation. Actually, it will depend upon the wavelength of the light, right? Because we are using the same light, we are only talking about the that intensity is reduced, right? So if we change the wavelength or if we change the source of the light, so then the separation will be different. But if we are using the same light, same monochromatic light for the experiment, so your intensity will reduce, but your fringe separation will remain same, right? So no change in fringe separation, right? And we also discussed that the intensity of the light passing through each slit was initially the intensity of light through one of the slit is now reduced. So after passing through that one slit, your appearance of the bright fringes will be changed like this. That the point where you are getting bright fringe, you will get now dark fringe, and the point where you are getting dark fringe, now you will get bright fringe. So actually there will be some shifting of the fringes, but their fringe separation will remain same. So actually bright fringes gets darker and dark fringes get brighter. Okay.